Another thing that's worth noting is that substitution works even if it doesn't actually lead us to to an antiderivative. I know that it goes against a lot of people's grain. You say, wait, the point of math is to start with the problem and get an answer to it. That is often the point, but the math works even if it doesn't lead you to an easier answer to a problem. So what am I getting at? What I'm saying is I can perform any substitution I want. Usually you're trying to choose u in a way that makes the antiderivative fairly easy to find once you've made that substitution. But even if you make a terrible choice of u, the fact that the resulting integral is equivalent to the first one is still true. So in this case, let's use the substitution u equals x to the fourth to rewrite this integral as an equivalent integral. So if u equals x to the fourth, then du is equal to 4x cubed dx. Now, I don't actually see 4x cubed dx in the integral, but I do see 4x to the fifth. So the integral is going to be equal to, let's see, this is the integral. We're going to put in the limits of integration later because we know we're going to have to change them. This is going to be 4x cubed times x squared. In other words, x cubed times x squared gives us that x to the fifth that you see. Tan x to the fourth dx. All right, so I can certainly, if I just rewrite this a little bit, get x squared times tan x to the fourth times 4x cubed dx. And we readily see that this is du, and this is tangent of u. Now, what's this? Well, if u equals x to the fourth, I'll use a different color here. If u equals x to the fourth, then that means the square root of u is equal to x squared, right? So it means I can rewrite the x squared as the square root of u. So this integral equals the integral of square root of u tan u du. Oh, and also let's not forget to put in the limits of integration. Let's see. Since this is still in variable x, I'm going to keep the original 2 and 3. But now I need to take 2 to the fourth power, which is 16, and 3 to the fourth power, which is 81. So this is an equivalent integral to the original expression. In other words, the integral in the box is equivalent to this integral up here. The fact that we have no real idea how to find this particular antiderivative and solve this problem doesn't change the fact that these two integrals are equivalent to each other. So that's really the point here, is that u substitution is really a way of changing the variable and transforming one integral from one to another. We try to choose u wisely so that it gives us an expression where we can easily find an antiderivative and hopefully solve the problem. But even if we choose u poorly, the equivalence of the two integrals is still true.